I present to you a part of my thesis. Actually, the thesis was about agricultural productivity and food security of rice-producing households in Ghana. I looked at two various dimensions of the problem. I looked at transparent and efficiency. So for today's presentation, I'm going to focus on the efficiency aspect of the study. I must say that throughout my not so extensive research career, food security and hunger has become a very big issue that I've always wanted to look into. And I must say that that drive is from, I took that drive from a quote from one of the illustrious sons of Ghana, Kofi Annan, and he says that, unquote, he says that the eradication of hunger in itself is not, sorry. The eradication of hunger is not an end in itself. It is a first step towards sustainable development and progress in development. And a hungry man is not a free man. And so we can say that there is a link between development and hunger situation in many developing countries. Now, when we look at the world hunger map, we realize that there is almost food insecurity in every part of the world, but that is more predominant in sub-Saharan Africa, as you can see, just interpreted by this color coding, and the deep shaded areas on the map shows the problem areas. And you can clearly see that this is the map of Africa, and you realize that most of the deep colored areas are located in Africa. So we have a major food security problem or major hunger situation in Africa. Now, at the same time that we are coming with this problem, this is how the population distribution of the world is going to be like by 2050. So realize that Africa is going to double its population by 2050. So at the same time, we have food security hunger situation. You've not been able to address that problem, and then population is also increasing. So the question is, how do we resolve this problem? Remember the quote, he says that there is we need to address hunger for us to be able to sustain development. So over the years, development partners, various government agencies have come to identify ways and means of improving hunger situation in Africa. They've tried to identify some crops that are key to eradicating hunger and malnutrition in Africa. And one of those crops is rice. And so in most part of Africa, rice has become a food security crop, and Ghana is one of the major areas in Africa where rice has become a major food security crop. At the same time that there is high demand for rice in various parts, supply is not matching up with demand, and therefore we have had to resort to importing rice from many other countries, such as Vietnam, Thailand, to be able to make up for the domestic shortfall in demand. Now, the critical question is, as a country and possibly as a continent, do we have to really continue to import rice to meet the dietary needs of people, or we need to consider the aspect of improving domestic production of rice? Now, researchers have found that the production chain tends to have many people compared to the marketing, the supply chain. And so when we produce rice, we end up improving the living standards of farmers and all those that are along the chain of rice production. And so there have been proposals to improve domestic rice production in Ghana and Africa as a whole. When it comes to increasing rice production, there is a major problem with productivity. And low productivity issues is not only about Ghana, but it's about major countries in Africa. We have low agricultural production. So the question has been, how do we improve rice productivity to be able to reduce hunger and malnutrition? Various development economies have two various divergent opinions. There are those that believe that we need to introduce new technologies, and out of new technologies, we'll be able to improve productivity in what we have termed as technical change. That is going to arise from good technologies and high adoption rates. Then there's another school of thought that believes that we don't have to really invest money in introducing new technologies, but rather we need to improve the managerial skills of farmers, because it is very expensive to develop and introduce new technologies to farmers, and therefore we should consider the aspect of improving the managerial skills. And increases in productivity, that comes as a result of improvement in the managerial skills of farmers. It's what we refer to as technical efficiency. And we say that technical efficiency is influenced by good institutions and extension services. So basically, these are the two main divergent opinions in the literature. But in reality, we can say that there is a relationship between technical change that arises from the introduction of new technologies and technical efficiency. Because in some instances, we need to improve the managerial skills of farmers to be able to efficiently utilize new technologies that are introduced. In other instances, too, we need to introduce new technologies for farmers to be able to be efficient in their production process. So basically, I would say the whole thesis was bogged down to this conceptual framework. That's how I'll describe it. Now, for the purposes of today's presentation, I'm going to focus on just the technical efficiency aspect of things. When it comes to estimating technical efficiency, there are some key techniques or key issues that have to be addressed. The issue of heterogeneity or variation among farmers in different production environments. In the production economics literature, what has happened is that mostly we use a stochastic frontier approach in estimating the efficiency of farmers. Now, the stochastic frontier approach is based on a common assumption that farmers are using the same technology in their production process. But in reality, there are variations in the production environment of farmers. And for that matter, we need to be able to account for this variation to be precise about the efficiency estimates that are derived from our studies. Oria and Kumbaka in 2004 pointed out that if we fail to account for heterogeneity in our modeling, then there's going to be a bias in the efficiency estimates, and that is going to influence the policy conclusions that are drawn out of such studies. And therefore, we therefore sought to reassess the efficiency levels of farmers in Ghana using models that account for heterogeneity. And that leads me to my objectives, that is to measure the extent of efficiency of rice production and to also decompose efficiency into technology and efficiency gaps. In doing this, I used a model, the Metafrontier approach. And by Metafrontier, you are looking at the maximum potential technology in the industry. And it enables you to also compare the group or the regional level efficiency to the overall efficiency in the industry to be able to determine which of these farmers is efficient or not. Just to illustrate that, so in the typical input and output relationship, assuming we have two groups or two regions, we are saying that the meta-frontier is what the overall or the maximum output, potential output in the industry, and that envelopes the group frontiers. You know, the meta-frontier and the group or the regional frontiers. Now the distance between a particular unit or farm or farmer and the regional frontier is what we refer to as technical efficiency. And the distance between the regional frontier or the group frontier and the meta-frontier is a technological. So that is the Metafrontier Concept. You have groups or regions, and then you have the overall technology in the industry, and you are comparing and decomposing based on how efficient individuals are relative to the group frontiers and how various groups are efficient relative to the overall technology in the industry. There are two key issues that come to play when we look at this Metafrontier approach or concept. And the first issue has to do with the method that is used to estimate the meta-frontier. In natural sense, nobody knows the true frontier. So how do we estimate the meta-frontier? And I must say here that the meta-frontier is a two-step approach. The first step or the first stage is where you estimate your group frontiers or the regional frontiers. And then the second stage is where you estimate your meta-frontier. So when relating to the method that is used to estimate the meta-frontier, O'Donnell, it's 2008, Battese and co. Came up with the use of the linear programming approach. But what it means that the first stage estimation uses stochastic frontier analysis to estimate your group frontiers. And they use a deterministic function or mathematical programming or linear programming to solve your meta-frontier. Now, there's a problem with this methodology in the sense that because it is deterministic, it does not account for noise. When it comes to data from particularly developing countries, there are some errors on some noise component that have to be accounted for. And so using this methodology is going to bias our estimates. Using the deterministic approach also will end up affecting, we are not able to establish this kind of statistical properties on the meta frontier to be able to make inferences about the estimates. To address this problem, Hang introduced a stochastic meta frontier approach. By that, it means that we estimate the group frontiers using stochastic frontier analysis, and then we estimate the meta frontier also using stochastic frontier analysis. So that addresses the issue of the deterministic nature of the meta frontier. I must say here that Hang's model is very beautiful. I mean, you're able to address some of the challenges in the linear programming approach. But then there are also issues about the consistency of the standard errors that are generated. The second issue when it comes to the meta frontier is how we construct the meta frontier or how we define support for the meta frontier. As I indicated earlier, we don't know where the meta frontier is. We don't know what the true frontier is. So how do we estimate something that we don't even know? The standard approach in the literature has been the use of the expected output of the stochastic frontier. So what you do is that you estimate your group frontiers, you pick the estimated values from the group frontiers, and you estimate your meta frontier. Then the second approach is where, in this case, you're going to predict output for each observation in your data set and use that as your Y in your meta frontier estimation. And that's how come we're able to estimate this function as stochastic. Because in that case, we have observation for every individual, so we can have our X and our Y relationship to estimate our meta frontier. So these models basically have been estimated using the maximum likelihood approach. And the issue here when it comes to production frontier estimation is that our models have to be theoretically consistent. They have to be monotonic and they have to satisfy quasi-concavity constraints and concavity regularity restrictions. So what we do in this case is that we introduce another dimension of how to estimate our meta frontier. We move away from the classical or the maximum likelihood estimation into a Bayesian approach. And so what we do is that we estimate both our group frontiers and our meta frontiers using this Bayesian inference approach. And this methodology has various advantages. In essence, it addresses some of the challenges I have raised earlier on those models. So we're able to establish our statistical properties of the meta frontier, and we're also able to identify alternative meta frontier supports. We can also ensure that the estimated functions satisfy the regularity conditions. So that's the extension that we have sort of made to the literature, up to where we have the maximum frontier estimation, and then we have introduced the dimension of Bayesian stochastic meta frontier approach. That hasn't been done anywhere. That's the very first time that this approach has been applied to a meta frontier estimation. Okay. All right. So what we do is that we now apply our models to a data set from Ghana, and we considered two regions. So we have the Upper East region and the Northern region. That's the map of Ghana. That is the expanded area of the selected regions. We used a total sample of 436 in our modeling. The outputs used in our estimation is rice output, and our inputs are labor, intermediate inputs, and land. So we first estimated our Bayesian group frontiers, and then we estimated our Bayesian group frontiers, which gave us the efficiency levels of the individual groups or regions in our sample. And the regions are the Upper East region and then the Northern region. And then we use the Bayesian group frontier estimation to identify other support for the Metafrontier. And so the results from the group frontier estimations were then used to estimate our Metafrontier. So the first thing we did was we wanted to compare the methodology that we are introducing to the existing methods in the literature. So the first model we estimated was a standard linear programming model of O'Donnell. And then the second model we estimated was the Hanks model. But instead of using the maximum likelihood estimation, we used a Bayesian approach. The third model was the Bayesian estimation using an upper confidence bound. So in essence, we are saying that instead of using the expected average of the group frontiers to estimate your Metafrontier, we can equally try to identify the maximum technology in the industry and use that as a basis to construct our Metafrontier. Because in reality, we don't know where the true frontier is. And the fourth method we used is that instead of using the individual observations to estimate our Metafrontier, we use the predicted Monte Carlo output draws. So when we estimate our Bayesian group frontiers, we use the draws, entire chains from the group frontiers to estimate our Metafrontier. Now in here, we use a linear programming approach because we have a huge chain of individual observations such that we will not be able to run a stochastic frontier model on that. I think I attempted that in the computer. The model failed to run because it was a very huge data set. So we used a linear programming approach. But I will show you the results and then compare the standard model that uses the predicted output of the individual observations at 436 to where we use the draws from the model estimation. There are some quite interesting similarities in the results that we think it's quite interesting to know, and that will also influence future analysis of Metafrontier. Okay, so that's basically what we have done. It's a bit complex now. So just to recap this, I said the Metafrontier estimation is a two-step approach. In the first stage, you estimate your group frontiers, or what you call the original frontiers. And in the second stage, that's when you're going to construct your Metafrontier. And so we're going to construct your Metafrontier using information based on the group frontiers. Now, in doing that, we can use the expected values of the group frontiers to construct our Metafrontier. Or we can use the predicted output from the group frontier estimation to construct our Metafrontier. We could equally also identify the maximum output in the industry in the group frontiers and use that as a basis to construct our Metafrontier. So that's basically what it is about. Trying to identify alternative ways of constructing the Metafrontier other than the standard approach in the literature. And also trying to introduce stochastic estimation methods instead of focusing on only the linear programming approach in the Metafrontier estimation. Okay, so let's look at our results. Now the GTE, so let me once recap again. So we have a standard, LP here is linear programming. So we have a standard linear programming model. That is where you first estimate the group frontier using stochastic frontier approach. You estimate your Metafrontier using linear programming approach. And then we have the Bayesian stochastic Metafrontier. You first estimate your group frontiers using stochastic frontier approach, and then you estimate your Metafrontier also using stochastic frontier approach. But in all these, you are doing those within Bayesian framework. The third model here is the Bayesian stochastic Metafrontier. But here you're using the highest technology in the industry, the upper bound of the group frontiers. The upper bound output of the group frontiers to construct the Metafrontier. And the last one also makes use of the outputs of the group frontiers by using the entire chain or the entire draws from the Bayesian simulation instead of using your raw observations in the data. Okay, so we have two regions, region 1 and region 2. GTE is the group technical efficiency. That's the efficiency relative to the group frontiers or the regional frontier. And we have the meta-technology ratio. That is the gap between the group frontier and the meta-frontier. Then we have the overall technical efficiency. So this is what has been adjusted this value has been adapted by just a multiplication of the GTE and the MTR. Now, there's a repetition of these numbers simply because you have one group frontier estimate for all the models. So whether you are using standard LP, the Hanks model, upper confidence, or MCMC, it is the same group frontier estimation. So whatever value you get for the group frontiers is the same that runs across. That is why you have the same values repeated across the models. And I must note that at this point, we cannot compare these two regions and say region 1 is technically efficient compared to region 2. For the assumption that they are operating under different technology, so the efficiency values here cannot be compared. But we can compare the efficiency relative to the industry's frontier. So what we see here is that farmers in region 1 have the opportunity to improve their efficiency of about 18%. Because currently they are producing about 82%. So 82 of that, 0.82 of 1 is 18%. And then the farmers in region 2 are just producing about 61% of their regional frontier. It means that they also have a room to improve their output by about 39%. And that is the average of the two groups. Now let's have a look at the technology gaps. So this is where the alternative models come to play. This is the key thing that we are trying to examine. Now, when we observe the values, we realize that, first of all, let's consider just the values on the basis of region before we look at model comparison. Now, if you look at the table carefully, we realize that the technology gap of region 1 is higher relative to region 2. So we can say that region 1 is more productive and closer to the available technology in the industry compared to region 2. And these are the averages. Now, if you look at the individual models, you realize that there are some slight variation in the technology gap estimates. But what I'm quite interested about is the Bayesian estimation using the Hanks model and then the predicted output, so the second and then the last one. Well, you observe that the values are quite comparable. And so what we can draw from here is that even though we use linear programming approach in this function, because we have made use of the predicted output, for each observation, the values are quite similar compared to the other models. So that's what I think is quite interesting here. So the issue really is not about just establishing statistical properties of the Metafrontier, but also about how we construct the Metafrontier. I think that is one of the key things that is coming out of these results, because you can really observe clearly that there are some variations in our estimates. But the interesting thing is that the values, there's a positive correlation among the alternative, some selected models. So we just selected 3 models and then constructed correlation to just compare to see whether they can give some consistent results. Assuming we opt for 1, 2, or 3, and there's a positive correlation, so that's quite interesting. But in terms of the values, there are some variations in the values. That has to be noted. Now let's have a look at the overall Metafrontier efficiency. Okay, so we observe that this is where we can say that region 1 is technically efficient compared to region 2. Because here the overall technical efficiency has been adjusted for the variations or differences in the production environment. And so what we observe from here is that region 1 is more technically efficient compared to region 2. And that is what we sought to establish. But when you look at the average overall technical efficiency, we can say there is still a lot of inefficiency in rice production in Ghana. On average, you can talk about 38% inefficiency. So it means that we still have a lot of work to do in terms of improving the efficiency of farmers in Ghana. Okay. So, what are the main findings from this different alternative modeling of the Metafrontier? The key thing, I think I've summarized this before, is the fact that region 1 is more productive and closer to the overall industry frontier. It is also more technically efficient. And The key point here also is that the technology gap estimates are quite sensitive to the method that is used to construct the Metafrontier. And that's going to have a lot of influence on the conclusions and policy recommendations that are drawn from such studies. But just a quick one on the policy implications. So that is the map of Ghana. We have the Upper East region, we have the Northern region, and I must say that the two regions constitute about 66% of overall rice produced in Ghana. So that's what makes this study quite interesting in the sense that whichever policy recommendations that are drawn from the study is going to have a lot of effect on improving rice productivity in Ghana. So on the basis of our results, we can say that we can improve the rice output in region 2 by about 89%. So there is still a room for improving rice productivity. But that of region 1 can only be improved by about 18%. And I think this one draws back to the initial point I made about the contention in the literature, about whether we should focus on improving efficiency, technical efficiency, or we should bring in new technology. I think this approach that we have used helps out with the problem. If you realize that a particular region or group is closer to the industry frontier, then it means that they will need new technologies to be able to shift or move beyond the frontier, the group frontier. Now, if a particular industry is way below the regional frontier, then we need to help them to get to the regional frontier. In other words, what I mean is we have to improve the technical efficiency of these farmers. But if they are already operating on the existing technology, then we need new technology to be able to push them out and to be able to produce more output. And that's what we observe. We observe that this region is highly inefficient. And so in terms of policy, we would have to focus on improving the efficiency and the managerial skills of farmers in that region. We talk of education, extension services, among others. For the farmers in this region, they are very close to the existing technology. And so introducing new technology would help in improving productivity of the farmers. Okay. So in conclusion, we said that overall there is about 38% inefficiency in rice production in Ghana. And all things being equal, it will be more beneficial to invest in improving the managerial skills of farmers in the Upper East region of Ghana, and also introduce new technology to improve efficiency of farmers in the northern region of Ghana. And the key aspect of these findings is the fact that the method that is used in constructing the Metafrontier is very important because it affects the technology gap estimate, which will end up have effect on the overall efficiency estimate that we derive from our models. And so if we don't consider the alternative formulation of the Metafrontier, it's likely that we're going to have issues with biased conclusions and policy recommendations. So it is very relevant and important for us to consider alternative ways of constructing the Metafrontier. I think that's one of the key things that we sought to do. Compare the different methods, introduce new ones, and see which of them does better and what we can do to push the literature forward. So in the course of this research, we came across a new study that tried to calculate the exact distance between the group frontiers and the Metafrontier. And it basically focuses on using simulation techniques. So as a next step, we're going to focus on estimating that function and see how that varies from our results. Another thing that we would do is to try to run a Monte Carlo experiment because there are different models involved here. So we need to be able to establish the circumstance under which each of these models function, whether when we have a very high efficiency farms, low efficiency farms, number of inputs, effect of number of groups, effect of sample size, then noise level in all of these groups. We need to be able to establish this so that we can clearly say that this model is better than that. And given these circumstances, we can use this model, or we can choose that model over that. And I think that is something that we would like to look at next. Thank you.